Today we are talking about heat pump technology. So first we will look at a heat pump water heater. So as you can see in this picture, a heat pump moves heat from the surrounding ambient air and transfers that heat energy into the water inside the tank. Number two, you see there's a digital display that has 3 programmable operating modes. And the number 3 there above the compressor on the top of the water heater, basically a fan takes in ambient air through a filter. The air travels through the evaporator coil. The coil contains refrigerant, which is it absorbs that heat energy in the air. The refrigerant is pumped through the compressor, which increases the temperature of the refrigerant. The hot refrigerant is circulated through a closed loop coil that wraps around the tank. The heat energy is transferred from the hot coil to the water inside the tank. The tank itself is surrounded by a thick layer of insulation to help trap the heat inside the tank. There are also dual heating elements, usually electric heating elements, for periods of high demand. A glass lining coats the interior of the tank to protect the tank from corrosion. Number 8 is a sacrificial anode rod. Number 9 is a temperature and pressure relief valve. It's a safety valve. And then number 10 here, these are UL 174 and UL 1995 certified. And a lot of times there's rebates available if you buy a heat pump water heater. They generally are a little bit more expensive initially, but they're actually more energy efficient in the long run over a standard gas water heater or electric water heater. So now we move on to heat pump HVAC units. And honestly, if you were to see one on the outside of a building or a house, they look almost identical to a conventional air conditioning unit. Some key notes. A reversing valve is the key difference between a heat pump and a standard air conditioning unit. The reversing valve allows the refrigerant to flow in both directions, depending on if you are in cooling or heating mode. Heat pumps are more efficient than standard HVAC units. According to the Department of Energy, heat pumps can reduce electricity usage by as much as 50% plus or minus compared to electric resistance heating, such as furnaces and baseboard heaters. Heat pumps do not work as well in extremely cold climates, so heat pumps usually will have auxiliary heat strips built inside of them to aid in heating in extremely cold climates on very cold days. But even in very cold weather, heat pumps can find heat in that outside ambient air to help warm your house. There are 3 main types of heat pumps connected by ducts: air-to-air, water source, and geothermal. They collect heat from the air, water, or ground outside your home and concentrate it for use inside. Usually heat pumps also oftentimes will have rebates that are available. So heat pump modes. So the chart on the top shows when the reversing valve is in position A for cooling mode, you see the refrigerant flows out of the compressor through that reversing valve, through the outdoor coil, through the expansion valve, then through the indoor coil, and then back through the other side of the reversing valve and back into the compressor. However, if you look at the bottom diagram, you see in position B, in heating mode, the flow is the opposite. So basically a heat pump works like an air conditioner in reverse, in heating mode anyway. Another nice thing about heat pumps is what's helped make them more energy efficient is usually the compressors are a variable speed. So here's a more close-up view of a heat pump reversing valve. So you can see in cooling mode the flow from the compressor discharge, and then you can see in heating mode the spool moves over and you can see it flows through a different line. So now we move on to heat pump clothes dryers, sometimes called condensing dryers or ventless dryers. A lot of these are Energy Star approved, and again, sometimes there's rebates for these. Basically, the way these work is as a drum rotates around, the moist air in your clothes flows through the condenser, and the humidity or that moisture is captured and removed, and it's collected in usually a drain pan underneath, condensate drain pan. And then the air flows through the evaporator where it heats the cool dry air, and then the fan circulates that cool dry air back through your clothes in the drum, and the process repeats itself. So the hot dry air goes in, it's going to pick up more of the moisture from your clothes. That warm moist air again is going to go through the coils, moisture falls out, and again it just keeps cycling that way. And these usually have an inverter brushless motor and an inverter microprocessor. And the condensate that's collected is clean water, and it usually is, you can have a hose that goes to a floor drain, or there'll be a condensate drain pump that can pump it out to the sanitary sewer system, or some dryers and washer combinations can even use the washing machine pump to pump the water away, the condensate away. So heat pump dryer advantages. They are easier to install since they do not require ventilation. Also reduce fire danger there because you don't have to worry about ductwork becoming full of lint and potentially catching on fire. Usually there's rebates and or tax incentives available. Heat pump dryers can reduce your energy usage by at least 28% plus or minus compared to standard dryers. They usually dry laundry at lower temperatures, so they are gentler on your clothes. Now, because they dry your clothes at a lower temperature, they do run a little bit longer to dry your clothes. However, even though they run longer than a conventional dryer, you'll still save money on your electric bill because they're so energy efficient. Another sort of green advantage that I really like is, again, that collected condensate water can be harvested as an alternative water source. They do require maintenance, so the filters need to be cleaned out periodically per the manufacturer's instruction, and of course you'll have your lint screen that also needs to be cleaned out. I hope this information helps. Please like, share, subscribe, and leave me a comment for future video topics you would like me to cover. Thanks for watching.